One sample space I am interested in introducing you to is a deck of cards. Now, this isn't because I'm teaching anybody poker, okay? That's not what's happening. But deck of cards is very conveniently a familiar group of objects that have many different characteristics each. Every card in a deck of cards has a black card, has a characteristic of black or red, has a characteristic of a club, spade, diamond, or heart, and has a characteristic of a numerical designation. It is either an ace, often thought of as a 1, 2 through 10, those are all just numbers, and then what we call face cards, Jack, King, and Queen, and King. These are our face cards. Ace, for what it's worth, is not a face card. Okay, at best it's just a 1. Frequently in card games, ace is considered a high card for a variety of reasons. Depends on the game. But in our case here, ace is going to be 1, 2 through 10. Jack, Queen, King are faces. Okay. So when we're talking about probabilities, let's break this down. I'm not going to spend too long on this because you should be good at this. This is all review, by the way. Even the conditional stuff we do later today is review. Okay? But here it is, that notation. I want to talk through our language that we've been learning. P, probability of drawing an odd or a face card. Okay? Now, or is a funny word in probability. Or makes things inclusive. It makes things bigger. Or means one is fine or the other is fine. It generally makes probabilities or likelihoods larger. Okay? The word and is very different. And shrinks our groups. It doesn't sound like it. That should make sense. But for something and another thing to happen, right, that actually generally makes probabilities smaller, or makes things bigger. So we're talking about or first. Okay? So for instance, we're going to count out. Here's that counting I was telling you about. What are my odds? How many odds do I have? Well, I've got my ace, because we're going to count that as a 1. 3, 5, 7, and 9. And then for face cards, we've got Jack, Queen, and King. So I count 1, 2, 3, 4, 5, 6, 7, 8. 8 options here. Now, however, every suit has this 8. So really, we've got 8 times 4, so 32 options out of 52 cards. You will find that simplifies to 8 over 13. Okay? But once again, I want us to understand our notation here. Here, my desired outcome, my P, so my probability of, in this case, odd or face, right, is the number of ways that my event occurs, the event being odd or face cards, so P of 8 here, is the number of ways my event occurs. The number of ways it occurs, we figured that out, was 32. Number of elements in the sample space, again, we're seeing our notation work out here. The number of elements in the sample space, well, that's literally asking you how many cards are in the deck, which is 52. And thus, this is how we see our notation, our language, work out with probability here. I'll go quicker through these others. A diamond or a face card. Now, here's where or is a dangerous word, because or can double count things. We have to be careful about that. So, how many diamonds do we have? Well, that's easy. 1/4 of the cards are diamonds, 13 cards in each suit. So we've got 13 diamonds. That's easy. How many face cards do we have? Well, face cards aren't so bad. We've got 3 in each of 4 suits, so we've got 12 face cards. So it seems to me 13 plus 12 is, not 15, is 25. 25 cards, right? Wrong. No, it's not 25. Okay? You see, we've double counted some things, and boy, that's all on you. Okay, I can't give you a hard and fast rule for this. It's on you to be able to handle this kind of double counting. Okay? So you see, there are some cards that are both diamond and face cards. Well, specifically, the diamond face cards. The Jack of Diamonds, the Queen of Diamonds, and the King of Diamonds. Okay? We've got 3. So we have to subtract our overlap. This isn't right at all. We have to subtract. So 13 plus 12 seems good, but when we subtract our overlap, which is 3, we actually get, let's see, 25 minus 3 is 22 out of 52. And you could reduce that, but you know what? I'm not that interested in that right now. Okay? Again, I want you to see that, how you've got to be careful with or. Always watch out. Don't count, double count some things. This next one's going to give us a similar situation. Let's talk about a red card or an ace. So how many red cards are there? Well, that's half the deck, right? There are, let's see, half of 52 is 26. There are 26 red cards. How many aces are there? Well, if you play cards, you know that. There's 4 aces. But 2 of those are red. You see, 2 of the aces are black, and 2 of the aces are red. So it sounds like 26 plus 4 should work, but we have to subtract our 2 overlapped, 2 double counted. So really it's 28 out of 52. Be aware of that. Be able to think that through in more complicated problems, maybe ones that don't use decks of cards.